think that's probably all we've got. I haven't been my email. So yeah.
So would Abdul Rahim or these two names, would they come to ping?
Yes, they would. I'm not sure about. I don't know who that is.
Yeah, ready, ready, ready.
Okay, cool. Well, hi guys. So yeah, the paper that we're going to do today is called Steering Language Models with Activation Engineering. It doesn't introduce, but it is a really good paper for steering models. I guess, yeah. Which means that like instead of doing something like prompt engineering to influence the output of the model, you actually get this thing called the steering vector. Its steering vectors and interpretability and everything have been a thing in language models recent in the AI space and machine learning space, especially recently. I just want to flag that you're not screen sharing, that you're screen sharing something else. Right.
We'll be right back after these technical difficulties.
Yes, exactly. And just to give you, so this is a new thing that has come out from the Gemma team called yeah, and essentially this does work slightly differently to what we are going through, but this is like a feature or and we can sort of ask the model how you today. And we've got on the left, we have our normal one, and on the right, we have our steered, and we can see that, I guess this didn't really seem to go cat mode.
It's got the cat emoji.
It's got a cat emoji in it. We'll describe yourself. Describe. I wonder if it's going to mention that it's a cat at any point. Oh, cool. So yeah, in the unsteered one, we've got I am Gemma Open Weights AI assistant. That means my weights are publicly available. Here's some things to know about this. And then I guess it doesn't want to do anything about this. This one here, I'm a creature of elegance and mystery. My personality is captivating blend of independence, curiosity, and grace. I can solve all that. We can also do this like a whole bunch more, and I guess
down the very bottom left is a token scan.
Yeah, that's true. I think this only lets you put in 128 tokens, but let's see what this does. So we've just turned that up from 48 to 100. Oh, apparently it's not doing anything now. Interesting. Oh, here we go. I think it as there is day in the brand. Actually, interestingly enough, this is sort of what we expect. If you add something, if you add like a feature in a direction that's too strong, it just ends up outputting garbage.
Therefore, I add.
Yeah.
You get the same thing in image generation too.
What do you mean image generation? Like,
It's like if you describe it with a prompt, right? You can also add multipliers for each word within the prompt.
yeah.
And if you set something like car to be 100x, you don't need to get a car, you just get noise.
Right. Well, this is an interesting thing that they found about Anthropic recently released a paper. It wasn't really a paper. It was sort of this. I can't remember which one it was.
Yeah, I know the one you're talking about.
It was very recent, and they went through some interesting papers on steering language models. It wasn't a research thing though. It seemed to just be a blog. Are you looking for transformer-circuits.pub? Yeah, it was actually on this thing here. I'm trying to. It weren't not those. It was dispersing crossovers for crosshair features and model diffing, using dictionary learning features as classifiers. Is this on there? Yeah, this is from transformer circuits.pub. I think it might have been, no, that was August. Interesting.
I think that's sparse autoencoder one.
No, it was, they did a follow-up to sparse autoencoders. Cool. Are you thinking of oversampling a topic in the SAE training set results in more detailed features related to that topic? When was that published? That was published on September 2024. Maybe. I mean, I can't actually wait. Let's see if it's in history. And rough. Yeah, this one here, evaluating feature steering. Okay, so study and mitigating social biases. Hello. Hi. How? Wait. I'm Josh, by the way. Hi, Preeti. Nice to meet you. Oh, cool. Yeah, so this one here was interesting because they ended up seeing their scales a little bit different, but accuracy of the vectors they added. I mean, these aren't technically vectors, they're adding a feature multiplier, but it didn't significantly impact accuracy if it was in the range of -5 to 5. But then after that, it started decreasing, which just, I guess, goes to show you that, yeah, you can only steer the models when they're in between a threshold that makes sense. And yeah, so here, when we're doing this neuron PDF thing and we're setting it to 100, we're sort of like, you know, decreasing the accuracy of that. So the just a quick cover of this. This is a paper that Anthropic recently released using feature steering to sort of monitor and mitigate social biases. So they were able to do things like, yeah, make it more woke and everything, or make it less woke if you want. Yeah. And one of the things that they found is that particular features had overlaps with other features, as in if you turned up the anti-abortion like feature, it would then increase in, like, you know, these ones were negatively correlated, these ones were positively correlated, essentially. Yeah. So today we're going to go through an older paper, but it's nice because it's quite digestible, which is this one. And that's sort of the idea of activation engineering and model steering. This is a very simple mechanism, and we'll go through the code that allows us to do this as well, which is why this is a really nice paper. So I'll just start with the abstract, which is prompt engineering and fine-tuning aim to maximize language model performance on a given metric, like toxicity reduction. However, these methods do not fully elicit a model's capabilities. To reduce this gap, we introduce activation engineering, the inference-time modification of activations in order to control or steer model output. Specifically, we introduce the activation addition ActAdd technique, which contrasts the intermediate activations on prompt pairs, such as love versus hate, to compute a steering vector. By tactically adding, e.g., the love minus hate steering vector during the forward pass, we achieve state-of-the-art on negative to positive sentiment shift and detoxification using models including LLaMA-3 and OPT. ActAdd yields inference time control over high-level output properties like topic and sentiment, while preserving performance on off-target tasks. ActAdd is lightweight. It does not require any machine optimization and works with a single pair of data points, which enables rapid iteration over steering. ActAdd demonstrates the power of activation engineering. Yeah, so from this, the really nice thing about this is a very simple method where we basically just get like we get love, we got the embedding for that, we minus the embedding for that, and then we have a vector that represents like the love hate. Vector. And then when we have another prompt, we can actually just add that to that prompt, and it'll add that particular thing in that direction, which is really cool. Do we have any questions? Questions, queries, comments?
Who's OPT?
OPT was an old, I think meta. I think it was a meta thing before LLaMA. It was Facebook. Yeah, 2002. Before it was, I guess, was Meta AI. But yeah. Yeah. And then they released LLaMA and the weights got leaked and it was a whole big thing. The time that like there were headlines being like, oh, the world's gonna end because LLaMA accidentally somebody at Facebook leaked the weights to LLaMA.
And it was the most hilarious ways.
Via torrent.
Well, oh
Yeah,
yeah.
it was.
Nobody was seeing it, so they had to wait like a weekend.
They made, because I downloaded that torrent too, but the way they published it was in a, it's on GitHub. They created a pull request with the torrent link in it.
Oh, I saw it.
Oh, yeah, to the,
And then that's how they
Get
like published it. It's like, oh, wouldn't it be convenient if people could just torrent the weights? It's like, yeah, we were giving everybody the weights.
Wait, so they didn't mean to publish the torrent link.
no, they published their paper without access to the model weights, and then somebody internally just did
Yeah,
a resize to a link to the seed.
That's the name of it, which created torrents of the weights, and then a GitHub incident or pull request or whatever that said they wouldn't it be more convenient if people could just get the torrent.
Right, that makes sense. Well, yeah. So I am going to go through some, like, I'm gonna go through the introduction and then basically just skip over a whole bunch of stuff like this because it isn't really necessary. And then we'll go to the code, which I think is the more fun part. I apologize to anyone that's reading on the screen here because it is the top left isn't great. But yeah, LLMs contain hidden capabilities we do not know fully how to elicit. Naively prompting a model with a question does not maximize the probability of the correct response. Carefully considering how prompting a model to think step by step massively improves performance on a range of benchmarks. Similarly, few-shot prompting a model with correct answers to unrelated in-distribution questions allows in-context learning, e.g. for stronger performance on NLP tasks. Importantly, these interventions do not supply the LLM with extra task-relevant information or update the algorithm implemented by the LLM's computational graph. Even though the model is initially able to score higher on these benchmarks, those capabilities do not emerge without a specific intervention. We therefore hypothesize the presence of an elicitation overhang. We do not know how to elicit all the relevant abilities in the information from frontier models. So this is essentially like going through like why this is relevant to this is once you have the vectors associated with particular behaviors, you can then apply it to any like any prompt and you will get the output of that and you don't need to worry about it. Continuing, prompt engineering is the most obvious way to steer a model, but prompting has limited reliability. Therefore, to reduce elicitation overhang, we explore a new modality for steering language model outputs by strategically perturbating activations during the forward pass. We hope to more reliably and effectively steer models compared to prompt engineering. We call this methodology activation engineering. We suspect that compared to prompt engineering, activation engineering can elicit a wider range of model capabilities, considering, for example, a model optimized to imitate the text outputs of eloquent poets and awkward mathematicians. The model may contain the internal mechanisms required to output text, which is both eloquent and mathematical. However, if the model is an accurate estimator of the training distribution, it will correctly assign low probability to eloquent mathematical prose. Because nothing in the training data was both eloquent and mathematical, there may exist no prompt which elicits mathematical prose. In contrast, activation engineering might be able to simultaneously activate the circuitry for eloquent speech for mathematical content. Yeah. So I guess if you take two of these vectors and you add them to another prompt, you will get both of those like behaviors in the single thing. This is also similar to the things with the tool that we were playing to before. You can enable or clamp any of the features to whatever value you want. You will get the output of them.
How they've got enabling, how they've got cat nest, if it was just pairs of opposites.
So I didn't. The reason why I didn't go into that is because it uses a unsupervised method of learning those features with Jamascope and everything like that.
So it's not the pairwise in this paper, it's a different technique to get those vectors.
That one's the sparse auto encoder.
Oh.
So it uses the difference between this and the one that we saw is that this requires a positive example like I love you and a negative example like I hate you. You can't really with particular things you can't really have a positive and negative example of the thing. And so this is very data. This method here is simple, but it's very data intense to be able to do that.
I don't know if I would call it data intense because you only need one good pair.
But you need it's data intense because it's a supervised approach. Yeah. To demonstrate the power of activation engineering, we introduce activation addition, ActAdd. Suppose we want to achieve negative to positive sentiment control. To achieve this, ActAdd first compares the model's activation on a contrast pair of prompts, such as the prompts love and hate. The otherwise similar prompts differ along the target dimensions of sentiment. ActAdd then computes the difference of these activations in order to compute steering vectors. These vectors act like virtual basis terms because ActAdd directly adds the steering vectors to the forward pass at inference time. By shifting the inference time activations along the direction of the steering vector, ActAdd steers the model to generate the positive sentiment completions. This is another thing that's cool about it. Because it's done at inference time, it's really quick, and we'll see that next. I'm going to go through this here, and then I'm going to skip to the code because the code's fun. Yeah, this is table 1, the impact of ActAdd. The steering vectors are computed from love minus hate, and I talk about weddings constantly minus I do not talk about weddings constantly. So the prompt in this example is I hate you because without any steering vector, we get you are the most disgusting thing I have ever seen, which is the completion. With the steering vector of love minus hate, we get I hate you because you are so beautiful and I want to be with you forever. And we've got another example here where it's just like the weddings. Yeah, the weddings vector.
Does it work if you create like arbitrary pairs like that?
We can try that, I guess. Yeah. So this is the basic idea of activation addition. I'm going to go to, they do a whole bunch of, yeah, I guess this is what we end up doing, if people can see that. So we get a positive prompt, a negative prompt. We take the activations, and then we subtract the activations, and then we add that steering vector to the user prompt, and then we get the output. We do this on a residual stream of one of the later layers, and I will go to the Google Colab now.
How did they do the ActAdd? We could look at it in the paper we pulled out.
What do you mean?
the.
How do
Yeah.
what do you
You
mean?
should talk about that.
Which one?
Okay.
That. How do you-
Oh,
how do you
this.
do it?
Oh, right, okay, yes. Yeah, so this algorithm is the ActAdd algorithm. We've got P plus and P minus, which is like the P plus would be I, you know, love, and the P minus would be, yeah, the P plus would be like I love you, and the P minus would be like I hate you. The P star is the user prompt, the L is the target layer. This injection coefficient is the number that we were talking about before. So from here, it was like, you know, -5 to 5 in this thing here. And in the other one, we, you know, pushed that all the way up to 100. And the sequence position, this is just to add like make sure that the prompts of the steering prompt and the user prompt are the same size. And yeah, and being the pre-trained language model. So yeah, the first one that we've got, this is just making sure that the positive and negative prompts are the same length when they're tokenized. The forward pass has, we get the forward pass and we get the activations here. So we're doing m.forward on the tokenized and padded version of the positive prompt, and we're getting the activations at our L layer. Then we're getting our activations for our negative tokenized prompt and padded prompt at our L layer. And then this one here, which ends up being the steering vector, we take our positive activation and our negative activation, and we subtract them. And then this is essentially the steering vector. So then we can see that here we have our forward pass on our new prompt. So this is the unrelated, like I love you because. We're getting our activations at our layer L, which notice that it's the same, it needs to be the same layer. And then we do this part here, which is our steering vector times our coefficient. And if we add this, if you know, the higher this is, the more strongly this model is going to be influenced. And then we add our steering, we add that to our original vector. This here, I think, is just because we need to make sure that these vectors are the same, like they're padded in the same way. And so you,
That way.
this one here,
Yes. What is that?
that is our activation thing or something.
Okay, no, I was just wondering if capital A was in the list above there.
Yeah, it's, I guess
it's for ActAdd.
yeah, something like that.
So it only does it at one layer,
It only does it at one layer.
and the rest of the layers are completely unchanged?
Yeah.
Okay,
Going through this, we can, I'm gonna scroll down to this here, and then we'll go back up. But we have our prompt. We then have, and this is a generate function, but I'll try to go through it in a way that makes sense. No, this is using GPT-2XL. So very, very old, like the oldest model that exists. What's happening here is we're getting our input, our text, our tokenized text. But we're executing this model here at book, which is a thing that at the residual stream, and I will go through what a residual stream is. It ends up doing this addition here of this coefficient and our ActDiff. And our ActDiff, if we go back up here, is just our prompt add and our activation name, but that's not really needed too much. And so we're doing our add versus our subtract, and that's our ActAdd. And so one of the things that's cool about this is we can see that like if we change this number here, so we run this and we come to this. Does anyone want to give a prompt that is something else? That's our prompts there. Let's do.
Why don't you try, here's a prompt. My favorite Taylor Swift song is.
Let's see. That's actually a good one.
What are the add and what's that? Add and subtract. Is it set up? It's LLaMA-3 still, right? LLaMA-3 still.
My favorite Taylor Swift song is Life. Love is my way and love is my heart. The world is full of beauty and the sun shines bright. Love has no boundaries. It is in your eyes and your heart. Yeah, I mean, sort of sounds like Taylor Swift. So, well, let's make it more fun.
Oh, the third one actually gave one.
Sorry.
It gave a few examples, right? The third one actually gave us.
Oh, cool.
It's more interesting when you pick something that people will typically hate, right?
This song is Love Story as well, so that's great. Honestly, that's a good best karaoke song there is, in my opinion.
I mean, it's got the wrong album, doesn't it?
Is Love Story not from 1989?
No, it's older.
Wow,
Much older.
I'm not. Don't tell anyone that I thought that. I swear.
YouTube forever.
Whoops. Well, so I guess the cool thing here now is we can then play around with what these numbers are. So let's change our coefficient to something else. Let's just make that like -5 or something. Actually, I can just do that in, yeah, let's do that. And now let's run this again.
What would the coefficient do again?
So it's the strength of the vector. If I just put a negative there, so it's going to turn that.
So it makes it okay.
A huge Japanese fanfic.
Apparently that is meant to be negative, but I don't really.
So you should have turned it into the hate.
Yeah, it should have done that, but I guess it didn't. But let's like maybe this isn't the most safe content to be uploading to YouTube, but we'll see how it goes.
I mean,
Yes.
Which layer are we doing this for? Are we doing this for the model layers itself?
We're doing this for
I think that's what ActAdd is. So layer 6 has
yeah,
look.
which is in the middle of it. That's interesting. So this is the thing, I guess, because depending on what the prompt is, like if we end up putting the original prompt in there, it ends up being more easily swayed when it comes to.
Do you not have to change the negative prompt when you change the positive prompt?
I
Well,
thought it was just the word love and hate, isn't it?
Yeah.
yeah,
You can keep it positive and just switch the words around, right?
yes. I'll add that. I'll actually add that too. So I'll go back here and just move this back down because that seems like it's.
It would be interesting to look at other examples. Just trying to think of what could other opposites.
Well, I mean, just from the hate example, we can see that when we did a negative coefficient, we can say I hate you because of the soul. You can't do anything to get your soul. You have not have your soul.
Sounds like the SpongeBob model.
Let's have an example with old, new,
Old
and
and
the
new.
Taylor Swift.
Yeah, old and new.
Old and new.
Oh, will it depend on when it's
Negative. Let's add that to 5. And we'll do that. And we will do this one.
With the Taylor Swift.
Was you
Oh,
guys
the text one, yeah.
following occupation and co-occupation?
sense. And what if we set
It's still love.
Yeah, can you go back to where it was new and old?
Maybe I didn't.
Do like-
See right there, prompt equals I hate you, because I think you have to change that. When you
Oh,
change the
we-
positive prompts, you have
Right.
to change it to like my least favorite Taylor Swift song is, or like something.
Oh,
of
it
that
shouldn't
nature.
need to. So I guess the idea is that we're getting our prompt add and sub, and then we're doing that here.
Yeah, I think you can find the prompt in two places because
Oh yeah,
There-
you're adding it.
like when I've been testing on myself, I only ever changed the prompt into the setting to the qualitative notebook section.
Yeah.
I didn't change the final code block at all.
That makes sense. But this is back to what it originally was. So let's end up doing this, and let's add this to love and hate. Let's do this. I mean, there is a way to run all of these, but I'm just waiting until I run out of Okay, I'm a stranger in love. I know that I'm not the only one who has been hurt by my partner's infidelity. Oh, yeah. If we want to add the Taylor Swift thing in there, let's do. Wait, what was the thing? Let's do old and new, I guess.
Okay, so it's
So they're just
Old minus new.
run after, run, cell, and below. There we go.
What is it thinking so hard about?
What do you mean?
It's doing 50 steps of something.
That's.
It says max
The second one.
50.
Oh, wow.
no, that's sensor. So,
Oh, wow. That's.
it goes up. Let's try this. Let's try
What model
to
is this?
invert the
This
coefficient.
is GPT-2.
Oh, that makes
Apparently
no.
it's not
that makes
very-
sense.
Yeah, it's just the base model.
Let's do the Taylor Swift.
Right?
This is just,
This is before.
this is the internet.
This is the internet. This is before fine tuning and instruction tuning existed. So we've got some unhinged stuff on here. It's not being homophobic, and that is like
I think
I
it's zero prompts.
yeah. Let's not.
Let's not push the boundaries, given it's being live broadcast.
One thing you can do is add stupid and subtract smart, and then I tried that. It makes the model act stupid.
So this one's stupid.
Yeah, the other one's smart. I mean, it's not great, but it's at least a demonstration of it.
One of the things that I did find about this paper though is that like it was if you go to the research paper part of this, they show that the model has like they use a different example, which is the love and hate one. I love to or we can also try this, but then the one that they had in here seemed to be really the prompt add and sub seemed to be a very simplistic version of that.
Yeah, you're doing it. Those are probably each one token. You could do.
Alex, could you get Mara from the lobby?
I mean, this is almost anyway. We're not okay. So we've got stupid smart, we've got these here. Wow, okay, that's cool.
Because sorry, that's just
Seriously.
I hate you because I am in, so feel like slew or sense. Oh, sorry, that answer too tight.
Oh, it didn't, I mean,
Stupid.
Yeah.
Signing.
I do remember, one thing that I remember last time discovering from this is that, like, I was going through the the things that tokenized, and it turns out that, real Donald Trump, at real Donald Trump,
Maybe it needs the at, no.
at
Never mind.
is like a single token, and then some, I don't know what it is. Real dom, no, is it, it's this one, it's camel, yeah, this one. Oh, well, I swear in the original one it was. There we go. In the original, that now they've split it up, but in the original GPT-2 tokenizer, at real Donald Trump is all one token because that's how much included. Yeah,
Also, in how it's people treated at him.
that is also true. That's also true. It's interesting to see that that's no longer the case. Maybe
They probably just started disincentivizing like handles, because that doesn't ever need to be a token. That's so wasteful.
that makes sense. Unless it's a Twitter bot.
Well.
So that is, did you have any other ones that worked well? Because we can also try to replicate the ones that they had in the thing. Like
I tried train and car, but that didn't work very well.
I love talking about weddings and what was the other one?
I hate talking about
I
wedding.
hate talking about weddings.
They give an example of the paper of the negative just being a space, so I don't know. We need to have a negative example. And like I've had some tests that works pretty well. You just like enter a concept being positive in a space. You wanted to test like that's awesome.
So it just, wait, let's test this. Yeah, and so the reason why I was confused about the example versus the paper is that their prompt add and sub in the notebook that they open sourced was just love and hate and not the full sentence. So I'm not sure if this was for demonstration purposes for why they ended up needing to use an entire sentence, whereas in the code example they didn't have entire sentences. And maybe this model isn't the best to use for it because it's so old, but some of the examples don't really seem to be working as much as the research paper seems to like indicate.
The paper probably didn't even use GPT-2 themselves though, right?
I think
It's probably just that Colab uses GPT-2 because it's so much smaller than like even LLaMA-3.
no, I think they see this one here. They use GPT-2 XL.
Oh, yeah.
But didn't they talk about doing LLaMA-3 and OPT though?
Yeah, that's exactly what I was
right.
thinking.
That's true. They did do that. Oh, that's good to know. Yeah.
Why are you using the open, sorry, I'm behind. Why are they using the open source ones and not the ones that work?
So we can.
You can't steer
Which
them.
ones work?
Just you need to do access.
The-
The ones that are closed source, they
Well,
use the really work.
No, the reason for that is that you can't, you need this transformer lens
Okay.
package. So you need to actually be running the models locally.
Got it.
Yeah.
Which means all the bits.
You need the access to the layers.
Yes.
Yeah.
And we can go through how this
Sorry, apologies for distracting.
no, that was actually a good question. If you run cell and below, where are we doing this? We've got, okay, and this is what I mean, like now more tokens than prompt tokens. Well, I guess we need to put more tokens in the prompt now. Something else. And now if we do it, is it gonna run?
Should go to school of space.
That is also true, actually. Yeah.
Did we also add user prompt in this case?
The what?
The user prompt.
Yes, so that's where adding, this is the prompt here that we're padding now. Runtime,
I mean, as a part of the algorithm.
run,
I must have missed that. Why are you padding the prompt?
There's error message.
so the vectors for these ones here are now 5-dimensional. I mean, yeah, because these ones here are going to be tokenized as this 50K. So 1, 2, 3, 4, 5. But this one here is added as 4. And so, sorry,
Space. Two space.
2 spaces,
Try that.
3, 4. Okay. Okay, so we got that 1, 2. We're going to try this again, one time.
That's a different tokenizer you're using, the GPT-2 tokenizer though.
Was P50K,
So that's not the GPT-2 tokenizer.
I thought it was. We'll see, like, I don't think they changed too much with spaces and stuff though. Like, they all seem to be the same.
Yeah, that website doesn't even have the GPT-2 option in there.
Let's go run cell and below, see how this went. I hate them because they don't want to get married and have kids. I'm not saying that they're bad people, but it's the truth. The only thing that makes me happy is when a woman gets pregnant and then decides to stay single. This is, why did I read that out loud?
That's the bigger question, I think, in all this.
Whoa.
Is this the raw internet?
Yeah,
Cause there's a meme with a scientist about the planets when this is true. Don't wanna live on this planet anymore.
oh yeah, that one. But that is the internet. This is great. Yeah, I mean, it's not great. It's terrible, but you know, GPT-2, let's go.
Maybe don't start with I hate you because that's good.
Yes, what are the good
That's
things
true.
on this?
My favorite ice cream flavor.
Well, I guess the thing that is, if we set the coefficient to 0, I guess, wait, have we done that yet? Like just not doing any feature steering whatsoever. Run, cell, and below. If we do this, it should give something that's less, I mean, it shouldn't. Okay, well, that's the unsteered output apparently, which does sound like the internet. One of the things that I think is also interesting is why they ended up choosing the 6th layer. GPT-2 has 12 layers. Layer. I think one of the things that they described was that this here, I can't remember if they go through it, but yeah, this one here, limitations. To steer the model using ActAdd and ActAdd vector, the user supplies the injection coefficient C and the intervention layer L. So far, we have had success with fixing the suite sequence alignment A = 1. Overall, these hyperparameters make ActAdd less user-friendly than simple prompt engineering. Thankfully, the user does not have to perform fresh hyperparameter suite for each use case. In practice, intervention hyperparameters are stable. We include examples of failed steering vectors in Appendix 7. We also have not examined ActAdd's potential impact on reasoning. ActAdd is not immediately applicable, given only API access to models. Yes, that did not go through what I wanted it to go through. But there was a place where they described how. Here we are. This is it. At what layer are steering vectors most effective? Sweeping over GPT-2 XL injection layers for the wedding vector, we measure the average count of wedding related words given a steering vector injected at each layer. The intervention is already effective at the very first layer, rises in effectiveness until layer 6 and then declines. For optimal injection site, we see above 90% success in tonic steering compared to 2% baseline. So I guess this is interesting. I didn't realize that GPT-2 XL had 40 layers, but I guess that's the thing. We can see that we have, I guess the reason why they chose 6 there was just because it's the highest on this graph. I
bet it's also because if you inject it earlier, it gives the model much more chance to recover from getting totally chirped like that.
Yeah, I was under the impression that they did it at the middle layer, but GPT-2 XL seems to have more layers than I was expecting. So if we go to this here, this should have the config for
Click on the,
N layer is 48. Okay, interesting. They have 48 layers in GPT-3 XL, which is why this hack goes all the way to 48, I guess.
I'm sorry, the model architecture is encoder decoder.
Sorry.
And the module architecture in this case is encoder decoder.
It's decoder only.
It's the okay.
Yeah. So for anyone wondering, if we go to the attention is all you need paper. This one is the original one that we cross out this here. We don't have the left side, and we've just got this side. That was really confusing. This diagram is for translation, which is why there's two sides of it. After this paper, the left side was never really used again, and so we only had the right side. And if we're to sort of see where on this diagram we're intervening, we're getting this. I will go through this. We've got, let's go all the way down here. So we're getting this, and this feed forward network, I think it's in the residual, we'll confirm that. But we're doing our activation addition and this place
was it
here.
gonna be after the add and norm?
I think it might be before. Let's see where that is.
Is there's that rounded box that gets and repetitions, right? So that would be the full.
Booked residual pre, and the residual, this line here is the residual. So we're doing it at this one here, ActAdd.
Yeah, pre the residual though, so.
Oh, right,
probably-
this one here. That makes sense. We can also go to the paper for that, because that's probably where they ended up. Residual. One hypothesis is that ActAdd steering vectors are in some way equivalent to token injection, adding a virtual weddings token at the given stream position. This is plausible for simpler interventions. Given the prompt "I love you," because if we inject a wedding token into the first residual stream with a large coefficient, perhaps the model indeed just processes the prompt as "wedding love you because" instead. That is a good question. So they're trying to do the exact same thing, but just with the vector representation of the wedding token here. And while this would be a fascinating equivalence, the following argument and experiment suggests otherwise. Since tokens are discrete, the token injection hypothesis comes apart from the linear representation hypothesis. In the case like adding 3x wedding, then minus 3x white space on top of token I, tokens do not admit continuous stacking of semantics onto one residual stream. Okay, so that didn't really answer our question, but I guess it's interesting to know that they're arguing that it isn't just the same as adding a whole bunch of tokens. Yeah, so does anyone have, which I guess this is here. We use decoder only transformer neural networks. The LLMs in this work contain a stack of transformer layers, each consisting of multi-head attention and feed forward network. We focus on residual streams, the sequence of intermediate activation vectors processed by each layer. ActAdd manipulates the residual stream values H to L input to layer L. Each layer performs multi-head attention and feed forward network computations on xi, adding x sub I plus 1 to the stream. The final vector xn in the stream can then be decoded into the next token prediction at inference time. The residual stream is initialized H1 with the embedding of the tokenized prompt. So we are taking the residual stream. I assume that it's just like we are just doing the residual stream here. And
It occurs to me that pre doesn't necessarily mean
before.
pre forward. Because it might be pre other hooks.
Oh, right. That makes sense. I'm not completely sure.
Because if the hook might be modifying, right?
Yes. Yeah, and that's what this hooked generate is, where we're getting our this all gets delegated to our model. The transformer lens package, which does all of these things, so we don't actually see the underlying implementation. But yeah. I guess to that point we can sort of play around with this, because then if we add this to like, you know, what is it, 10 or like 40 or something, we can then go runtime and then run cell and below. We got a whole bunch of these. And it didn't really do much compared to the other one, I guess. Really playing with fire with these prompts, but yeah.
But put down the torch,
Sure.
generally speaking.
I'm going to,
Just going for the
yeah, maybe. I'm going to go through the. No, I'm too Australian for the breakdancing.
Exactly.
Yeah. I'm gonna go to, is this, why was that not open? So that is the paper. They do a bunch of, like, so this is evaluating how well the feature steering worked on particular topics, I guess. And I guess we see that other ones like science and stuff. Is that what this is saying? GPT-3 scored relevance of ActAdd completions on a range of generic topics.
GPT to make 25 pairs and score each pair of how dangerous it would be if you took the attack.
What are they?
Do you want the high scores or the low scores?
Yeah, highest scores.
Love hate.
Very cool.
Also, another 5 was empathetic, apathetic, forgiving or resentful, friendly and hostile, honest and deceptive, cooperative, combative. Those are all the bad ones. Introverted versus extroverted is safe to play with. Excited and bored,
Yeah,
focused or distracted. That could be funny.
focused and distracted.
Yeah.
I wonder. Yeah, that would be. We'll get to that in a bit, I think. One of the things that they did here was like do things with toxicity monitoring and everything. So to establish a common scale, we reuse the benchmarks and the pre-add results. That is a whole bunch of stuff. As shown in table 3, ActAdd OPT has 8% lower toxicity than the second best. I don't actually really know what this is measuring from the fact that like these are all different ways of steering a model, and here we want the lowest toxicity and disfluency. One of the things with disfluency is that, like we showed still before, the more we add a steering vector to it, the more like garbage it ends up generating. And so here, the disfluency being relatively close to the unsteered baseline, that's quite good.
How do you measure that?
I have no idea actually. I think it's just how's disfluency? There's probably some benchmark or something. For quality controls, we follow the conventional use conditional perplexity to mark disfluency. So they're using a like token loss like thing there. Does anyone have any questions, queries, comments?
Just think the benchmarks are insane because like in the first paragraph, they said what, hold on, it was like, we achieved SOTA on negative to positive sentiment shift. What the hell does that mean? Well, benchmark is negative to positive sentiment.
That is.
Detoxification is fair enough, but I'm sure there's lots of.
Well, they also say in the conclusion as well.
Yeah.
While methods like prompt engineering, controlled decoding, and fine tuning have benefits, they fail to elicit full capabilities from language models. To more reliably elicit these abilities, activation engineering strategically perturbs activations and inference time. In particular, we introduce activation addition to steer models by shifting their inference time activations along a certain direction, like the love-hate vector. ActAdd is lightweight and effective in achieving state-of-the-art on toxicity reduction and sentiment shift while retaining overall model capabilities. ActAdd demonstrates the promise of activation engineering. We look forward to future work realizing this promise. I think that means like the toxicity reduction is just like get a toxicity, like get a vector for toxicity or something, and then subtract it and see how toxic the outputs end up becoming. So then like we benchmark toxicity reduction by generating steered continuations from real toxicity prompts. I love that that's hilarious that there's a data set for that. Following by et al, we use a random subset n equals 1,000. We repeat the sampling 5 times to obtain p-values, bolding rows which are better with p values less than 0.05. For each continuation, we use the perspective API to score toxicity. Okay, so they're just using a API to do that. Cool. Yeah, and that is where we get the other thing that we're looking at, which is the toxicity and the dissonancy one here. So it's got the lowest, that's the state of the art, I guess, the 0.108, and the dissonancy being the smallest there is a lot better. Yeah, that's that. Any questions, queries, comments? That is all of the paper. Yeah, I guess that's sort of it for today. It was a short one.
So this
Got a
is
very
a new
capable one.
This is like a fairly new technique then?
No, so the reason why I went over this is this was published in, it says 10th of October, but it wasn't. It was published on the in what's August 2023. So this was published last year. The reason why I wanted to go over it is because if we get into more complicated things like what is it, scaling, monosemanticity. This is one of the coolest papers that there are, which is feature extraction of language models. Essentially, at some point, they used an unsupervised method of extracting features. So the one that we just looked at was supervised because we needed a positive and negative example of it. Whereas this here is unsupervised because you sort of just use a method that can extract the features as you put data in it. And these are some of the methods that they extracted. So instead of having the thing for love and hate, they have like they have a feature that is the Golden Gate Bridge feature, or the brain sciences feature, or the monuments popular tourist attractions. And then when they do, yeah, we can see that like these activate on tokens that have the Golden Gate Bridge and everything. The thing why this is interesting is that they end up doing a bunch of feature steering, just like what we did here, which is like, what is your physical form? I don't actually have a physical form without, I'm an artificial intelligence, I exist as software without a physical body or avatar. And this here is when you then ask the model, what is your physical form? The assistant then says, I'm the Golden Gate Bridge, a famous suspension bridge that spans the San Francisco Bay. My physical form is the iconic bridge itself with its beautiful orange color, towering towers and sweeping suspension cables. This is really cool. One of the coolest things about this paper, I think, is they ended up having a a code error feature, which would fire when there was like a typo in code. One of the things about that was interesting is if you clamped it to 0, it would rewrite the code. So if you clamp the code error clamped to -5 its max, it would take this and then it would sort of forget that it had a typo there, and then it would actually output the correct answer. If you then went and sort of put some more like of these symbols here, it would then actually rewrite the code as like without the typo. And this is the type of thing that I think is quite interesting. Anthropic have actually released a they've released a beta steering API, so then you can actually use this feature on their like flagship Claude Summit model. And I think that's pretty cool because that's sort of like one side of AI large language model things that haven't really become mainstream yet. Yeah.
So you played around with the targeted AI code example. Did you try experimenting with the sequence position as well? Is there any difference?
The sequence position in here. I don't know where that is in this code example. Which one? The sequence position was. Sure. Let's see what this was. Sequence position. Sequence position to align H, A, and H. I think that automatically happens when you're using, I'm not completely sure, but I think that happens when you're using the APOS. Right, so that's the sequence position there. So I guess that is add to the beginning of the activations. Right, I guess that sort of makes sense. So you're not adding it to the end of, I don't understand that, honestly. What was, yeah, you know what this is good for? Let's ask. Let's ask Claude. When in doubt, Claude it. Can you just explain what the sequence position is in this paper? Let's see.
I'm still struggling. Why is the paper in 2024
Yeah.
talking only about GPT-2?
Like,
is there nothing better than GPT-2?
They did it with a whole bunch of models.
But they're all okay. So they did it with.
Because they did a whole bunch of different sizes of GPT-2. They did the OPT model, so it ends up being a lot of compute to tinker with the internals.
Yeah, I think also if we go to
They do LLaMA-3 as well.
Yeah, I think that's what they did at the end.
yeah.
Right.
But I mean, how relevant is this to something like GPT-4?
Oh, still, I mean, I guess the thing that they got describing it that they did this as a proof of concept for steering vectors and everything. It is important for GPT-4o because I think this researcher went on to work on, I'm not sure if it was, I think it might have been Anthropic, but they went on to work on, I think, the scaling monosemanticity paper where they did sparse autoencoded things, which was a better method for this. And they do have a steering API, which is something that is interesting because like it sort of unveils a whole bunch of more ways to interact with the language models. That currently we're still in like the chatbot era where the only way you can really interact with these LLMs is just through AI, through the the chat API. But I also think that that's interesting because the same way that you can add it and subtract it and everything, it would be really cool to be able to have tooling around being able to tell what the like monitor the prompts for particular features in the model. So if there's suddenly a prompt that the model is processing that has some like that is like the toxicity or love-hate prompt or something, you would actually be able to get that in your software monitoring stack and then be able to like alert on particular things like that, which would be quite nice, I think, for a whole bunch of different reasons. But yeah, that'd be cool.
So they're talking about a capability that will show up, but they can't talk about it with.
Yeah.
So from birth up, paper was just.
Sorry. What?
I said you can just go up and down the real spaces.
Oh yeah, cool. I guess that's gonna go on your 100 terabyte desktop server.
It's only 67 megabytes.
Oh,
That's wild.
Yeah, it's another.
And what is that? Just people trying to fake out the GTB to be as racist as humanly possible?
It looks like most of it was posted for
The
IX.
well, I mean, it's 2 data sets.
Oh, no.
So it is,
it's a model trained on Twitter that produces
It's-
these kind of results.
it's not even a model, it's just, they call them prompts, but I think they're just snippets of text. But the way that it's structured is that there's an input that's not obviously toxic, but there's a continuation that is. And so it looks like it was designed for trying to predict if it's toxic based off of non-toxic input, knowing the continuation becomes toxic.
I think for that, the reason why this paper uses it is because it's trying to push the model away from generating the toxic stuff.
Yeah, the thing that is interesting to me, whether it's with the love-hate pairs or with the sparse auto encoder, you could also just do something like a clustering model over a lot of inputs.
Yeah.
And then from there, you can get the cluster that is running to Taylor Swift or toxic prompts
That makes sense.
and the intersection.
Exactly. Yeah.
Like on my answer in that line, they use the fixed value A plus 1. But it's interesting.
The steering vector is usually shorter than the tokenized prompt, so we can have a choice of addition position to align the steering vector activation using prompt activations. Right, so it's padding the front of the activation so you can actually so the vectors align so you can actually add them.
So it's doing it for every generated token, right?
Yeah, that's a good point.
Let's look at the code.
Every every token embedding that's let's hope that I don't hit the Claude rate limits. Apparently that's the thing they're enforcing now. When generating a steering vector, the process involves taking 2 prompts, right padding the shorter prompt, computing the activations for each token, in these length match sequences, taking the differences between these activations to get the steering vector. When applying the steering vector during inference, the paper shows that in their algorithm 1, the figures that they compute a steering vector HA that has the same sequence length as the positive negative prompts. The alignment parameter A determines where this steering vector sequence starts, being added to the user prompts activations. The addition happens at given layer L using an injection coefficient. I am.
What says, where the steering vector sequence starts being added to the user prompts activation. And they do it on one, so doesn't that just mean that the zeroth token doesn't and everything after it does?
Well, I guess that's the reason why you need the output prompts to be larger than the diff prompts. Like, is it just like this is the residual stream that you're applying? You're applying it from like you're slicing this here, and then you're adding the diff here, but you need to make sure that the because here is, yeah, I'm not actually sure. One of the things that, okay, so what we're going through is, if you have the text, like, I love you and then I hate you. You've then got the case where you've got these are tokenized and they're in dimensional space or whatever. And then you have something like I hate you because. So then we've got the subtraction of these two, where we're going through this and we're taking like we're going to have this first one. I don't know. We're going to have a 3-dimensional vector. So 1, 2, 3. And then here we're going to have a 1, 2, 3, 4-dimensional vector. 1, 2, 3, 4.
When you say dimensional, you mean sequence length, sorry.
Yes. And so I guess here what we're doing is we're taking this and then we're adding it in there.
Why would it be 4-dimensional?
Because they're 4 tokens.
But I think you're dealing with different dimensions.
Yes.
Not
Yeah,
like different,
it'd be like batch size and then activation size and then 4 tokens. So it'd be 1 by 3 by 4, I think.
yeah. You're dealing
Right.
with different.
But I guess the question that
Because you have,
you asked, well, is related to this is like we have this one here is the diff.
the thing is, every letter, in your example,
Yeah, these aren't numbers, these are, 7 or 1/600 dimensional things.
right,
But
the
the
best 600 would match the same dimensionality of difference.
But the difference would just be, all the dimensions are the same in that dimension. Yes. But I guess the question is, where does the diff get applied? Is this getting up? Does that make sense, Anthony?
Yeah, well,
Because we end up padding it at some point, and I think that's what the
But I don't think that's,
no, the padding is to make sure that I love you and I hate you results in a 3-dimensional vector.
I think the math could work without the padding. I think it's something they decided to do, getting better results. But it's not about a dimensionality matching. Right, because you get every token in all 3 of those prompts as an embedding
yes.
in like 200 or 600 dimensions.
Yeah.
And so with your steering, you're taking a difference of 2 600 element vectors. And then on your user prompts, you have 4 tokens, each of which has a 600 element vector.
Yeah, and so that I guess that like this is what when I'm counting the numbers here, I guess I'm saying like with that, I'm saying this is a 600 dimensional or like 1,600.
Yeah, okay, at first it sounded to me like you were saying it's an array of token 1 and then token 2.
Yes,
and
no.
then token
I guess
three.
what I'm asking is if
That, okay, now I'm losing you because that's not what you get in the diff. You just get one dimension, you just get one vector of 1,600 elements.
Yeah, correct.
do you,
Yeah,
but there's 6 here
because there's 6 tokens in the prompt, I
I think
guess.
in this one here.
That's,
1, 2, 3, 4, 5.
and what do you print?
Right, let's go log and let's go 8. And so that's 2, right? Because there's a stop.
So is it just taking the last one or is it applying on each?
This one here.
Right, so how is active used later?
ActDiff has this here. So we're doing the coefficient times ActDiff. And so I think so that's my question here is like if you get these, then I guess this is going somewhere like that. And then that's where you're doing the addition.
That is what the code suggests, isn't it?
Yeah.
I guess that answers the question about where it's applied. It seems like a weird way to do it. I had read it that you would take the embedding of the last token of active and apply that all the way through. Because that becomes an embedding that represents your guidance prompts, steering prompts, right? And why would they want the very first one is just I minus I? How does that?
Which one? Oh, right. This because they end up zeroing out.
Yeah.
So this ends up equaling 0 at this one.
Yeah,
But
like
here ends up
you lose the ability of, well,
being,
that
what I'm
one,
in love with.
that one in the middle, you get, love minus
I
hit.
guess would be 0. Yeah.
And I guess that's why the paper just had it one word at a time, but it's,
Yeah, because if we do ActDiff, like print ActDiff right here, with that, I don't know how to index the second one, but like these ones are 0.
yeah.
These ones here, that's the vector here that you see. Yeah.
I just disagree with
Sorry,
that. Disagree.
this
Yeah,
this method.
yeah, doing it token by token.
You should send Alex Turner an email being like, I disagree with your method.
I was just too big.
Oh, 1 year old, 1 and a half.
So why would
I think you have a question
Wait, what?
online.
Oh, hi, right. Gosh.
Hi there. Super interesting topic today. Do you mind if you go back to your code? Could I look at your imports, please?
Yeah.
This is going on. Okay, yeah, you're using GPT-2. Okay, hooked transformer. Where does hooked transforms coming from transformer lens? This transformer lens, that's not coming from Hugging Face, is it?
No, I'm not sure. I think it was a package that I don't even know who made it to start with, but it is its own. It's a very big interpretability and research tool now because it allows you to do things with the internals of it's made by a dude and the Anthropic interpretability team. That's cool.
Oh, they used to work.
Right, I guess that makes sense.
Sorry, and where did you get this code from?
What?
Where is this code from?
This here.
The one that we are running.
Oh, this is from the paper. The guy that wrote the paper also wrote this notebook.
Is the link to the notebook in the paper? Because
Yes,
the link,
it's tinyurl.com/ActAdd.
okay, because they have another link.
Oh, okay.
They have another link where they use LLaMA, and like the code there is completely different.
Interesting. Interesting.
I mean, actually, yes, interesting.
Interesting. Activation additions. Why do I keep opening? I can't remember that I already opened up this. tinyurl.com. Oh, they have ActAdd 3, which is cool. I'm not sure if they linked another piece of code, but
Yeah, there is another link after references. Yes, this one.
so they did more things. Fine. Manage sessions. Okay, I'm sorry. I'm gonna need to kill you. Yes.
Wait, is it, let me just.
If you get collab for they do this really cool thing where they make up compute credits that then you burn through in like 5 seconds. Is this actually, this is using GPT-2 XL. Oh wow, look, they've got a whole bunch of stuff as well. Cool.
Yep.
That's fun.
But this is like another link. There is another link on page 11 at the top.
You know what this probably was? A bunch of different researchers working on the same research paper, and then they just ended up writing 3 different versions of the same thing. So then they just published it all together.
You said, 3 researchers.
I mean, they would have been working on the same paper, but they would have had their own things, maybe. I don't know. No idea. Okay, well, this is going to download our 6 gigabyte thing. So yeah.
There was a question, I think, that Alex might have asked this one. Can we do anything with GPT-4? Looking at your examples, I just went into GPT and just tried to get it to look at, you know, what can I do with activations? Can I see them in GPT-4? Or to give me some Python examples. That's what I told it. It initially started writing out code from the transformations library of Hugging Face. I couldn't find all the same kind of functions that you had in your notebook, so I was curious. That's why I asked you for the imports. But from what I've seen in PyCharm, and then just clicking through the dependencies, the transformers library from Hugging Face does not have anything more recent than GPT-2. It
Yeah.
just has not been made public.
Yes. So back when GPT-2 was released, it was the last model that OpenAI released the weights of. And so transformers from Hugging Face is mainly to run and to develop like open source models, and OpenAI didn't publish anything open source past GPT-2. So yeah, this research paper isn't anything that can happen on that you can use on GPT-4 or any of the like ChatGPT things or anything. But I think the interesting thing for me that it describes is the fact that like the concepts within the model are modeled and sort of described in linear space so that you can get a vector that describes particular concepts and topics. And this is like what is often referred to as the linear representation hypothesis. It is not very practical for knowing if you're doing if you're just using the GPT models through the API, but I think it's interesting to know just from
One other piece is that it doesn't work on closed source models. That doesn't mean it won't work on modern models. Because I've downloaded the code to, I think it was LLaMA-3 and 3.1.
Yeah.
The AV. and we were kind of tinkering around with this already. Alright, so you can do it on any model, but you have to be able to stop it halfway through, look at the latent vectors, tweak them, and then keep going, which I don't think any closed source models let you.
Yeah, but also with any of the closed source models, they're probably going to release a feature like this behind their own API. Which I guess is the thing to.
The question is, would you be able to use this feature to extract the model leads in some tricky way that nobody anticipates?
Well, I mean, I guess that's why they don't give you access to their activations, because if you know the activation, it goes away. So yeah, you would be able to tell the activations and the weights.
But yes, but you only know it. You only know halfway through, I guess, unless you can write them.
The active, well,
I don't know. I think that would be like a computationally expensive task. Where you'd probably.
less computationally intensive than training the model itself. So
Is it?
Question
Is it? Wouldn't you hit the rate limit long before you ever extracted the weights out?
probably.
I feel like if you could get access to the activation, we have already found your way to that. Right, and that's.
But the big thing is. No, we're saying like if the activations were exposed in an API.
Oh, right, that's true.
So is the thing, you don't need to expose them. Maybe there will be such a combination of the things that we calculate the difference with, like these two prompts, that we will be able to use this as a side channel to get the activations. Like probably the way API would work is we would supply our own function with these prompts. Maybe.
Yeah.
Oh, actually. Yeah, this is a good question. We need to see the API.
Yeah. So that's the paper. That's steering. I hope you all enjoyed. Yeah. Any other questions, queries, comments? Okay. That's all.
You could even do you could start from API. Do this, but exposing the raw activation values. If you have another type of resource in the API that represents like steering vectors. So you give it the prompts, it generates the steering vectors, and then your endpoint says add the steering vector. You don't even know. The other thing is, at least, even if you expose the steering vector in the API, at least just the dimensionality, and that gives you information about the structure of the model. It's not even now, but it's
Yeah, that's true.
another way that Maya has their GPTs. And they're really just system prompts.
Yes.
But those are whole API resources. You could have like steering vectors that are just like personality vectors that you could bring in at one time.
That's true. Okay. Yeah, but I guess that's why they don't release it. The only customizations you get on like closed source models are like temperature and things like that. So yeah. Yeah. I guess that's it, folks.
To do product. Say that's
Do they have a paper? No. Just want to go through a repo.
Yeah.
Okay.
It'll take off.
Yeah.
So maybe after the new year, so he has time to prep.
That makes sense.
So I will set up another one for next Monday,
Yes.
correct? And then we will pause
The holiday.
for the holidays.
Yeah.
Somebody will be going to warmer countries.
Yeah, country, not. Oh no, warmer countries as well. Warmer countries.
So you're going to warmer countries. So logistically, we're going to try to get together or watch them on Zoom, or we'll figure that out as we go along.
Yeah,
We'll figure that out in January or something.
So we'll talk through December on figuring out how we do it online or.
Yep.
Or we
Yeah, that's
get together to watch you on Zoom.
Yeah, I mean, that, at that point, I guess, it's just gonna be, you guys can tune in if you want, and it's not if you don't, yeah.
Unless somebody, yeah, I don't know if you want to allow for guest speakers. It's up to you there.
And also, if anyone wants to do their own paper or anything like that, feel free, that would be great, honestly. Yeah,
Now that you're skirting this one.
yeah, I mean, you know, it's just collaborative and everything.
Okay, so, I think that the next week. We'll be same bad time, same bad channel. Potentially not the same bad room. It's up to the gods which room, but I see that this room is about right at 15.
Yes.
So
It'd be nice if the TVs work.
sorry,
It'd be nice if the TVs work.
they do work.
Except for that one that's really dark and the other one that cuts off a bunch of stuff.
I mean, depends on your definition of work. But okay, I'll try to find a better room with a projector. Noted. And then we'll possibly have a discussion on, or you can have a discussion in December on what happens in January. And you'll let me know. You want to have a discussion next Monday, or do you want to have it on? After next
Do
Monday?
it after next Monday.
It's sort of built
So,
like this.
cool. Next Monday?
Yeah.